أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم Assalamu alaikum class. How are you all? I hope that you all will be fine. Alhamdulillah, I'm fine. In today's video lecture, we will discuss the classification of antenna, and we have actually four types of classification. We will discuss one by one in detail. But before going to the classification, it is known that from the previous lectures that there are so many type of antennas, but the choice of antenna depends upon the requirement. And this requirement can be for frequency, can be for the specific polarization, gain, power, etc. So the person choosing the antenna for the transmission depends upon the application requirement. So here we are. Further, we move to the antennas classification. There are different categories of classification identified. The first classification is due to the antenna radiation pattern. This first classification is due to the antenna radiation pattern. In this classification, three categories are defined. Number one is isotropic radiator. Number two is directional antenna. And number three is omnidirectional antenna. In isotropic radiator, but remember that this classification is due to the or this classification is in aspect of radiation pattern. The first is the isotropy radiator. It has been discussed previously that isotropic radiator is defined as the hypothetical element which radiates energy equally in all directions. That means it is a radiator which equally radiates the energy in all directions. And the further it is defined that it is an ideal antenna, and there is no such practical thing is realizable because there is no such ideal antenna that can radiate energy equally in all directions. But we can use this radiator as a reference in order to compare our design with the isotropic radiator. The examples in the isotropic radiator are a point source and a star. They both radiates, or it seems that they both radiates energy equally in all directions. The second is the directional antenna. The formula is here for the power of isotropic radiator, which has already been discussed in the last chapter. The second category in the first classification is directional antenna. Directional antenna radiates or receive electromagnetic wave in a specific direction. That means if you want to radiate or receive electromagnetic wave in a specific direction, you have to use directional antenna. And the examples in the directional antennas are dipoles, horns, and parabolic dishes. The third type in the first classification is omnidirectional antenna. Omnidirectional antenna is defined as the non-directional radiation pattern antenna in which a non-directional pattern is observed in azimuth angle and a directional pattern is exists in elevation. That means omnidirectional antenna can give you a non-directional pattern in azimuth angle and a directional pattern in elevation angle. It has a special type of directional pattern. For example, it has a circular loop as an example, vertical Hertz antenna, Marconi antenna, and a quarter wave monopole. The radiation pattern of unidirectional omnidirectional antennas are shown in figure. That is the polar plot of omnidirectional antenna. That is the pattern for quarter wave monopole. The second classification, we move forward for the second classification. The second classification is depend on the size of the antenna, and that classification includes two categories. One is the resonant antenna and the other is the thing that should be noted here is this, that the second classification is with respect to the length, which is defined as the resonant and non-resonant antennas. Resonant antenna consists of the length which is equal to or the multiple of lambda by 2. These resonant antennas have open ends. These antennas are not terminated by any resistance. These are used at a fixed frequency. Resonant antennas consist of forward and backward loop. Standing wave also exists in the resonant antenna. Radiation pattern of these antennas are multidirectional. That means they have the multidirectional radiation pattern, and the current distribution in resonant antenna is shown in figure 6.2.